What's it like working on the Large Hadron Collider?
Well, there's different types of work. So there's what, 10, 20,000 people working on it, right? So the two main things that are concerning us right now in the runtime are the actual experiments are running. So there's the Atlas detector and the CMS detector. But we've had a 2-year shutdown in the last 2 years, a 2-year shutdown, long shutdown. And during that time, many of the systems have been repaired, upgraded. See, when you've got an accelerator, you get a lot of radiation damage and all these types of things, and you can't exactly go in there and fix it, so you have redundancy. So during the shutdowns, you go in and fix it, repair the magnets, repair all of the beam position monitors, and you get a feeling for how important it is to actually work in teams, because you're responsible for fixing this tiny little thing, and there's 10,000 of those tiny little things, and they've got to communicate and they've got to talk to each other and all those things. And so it's key that you actually do your job well, that it's well documented and integrated, and you work together as a team. Restarting the Large Hadron Collider, who knows how long it's going to take? Probably about 3 months to condition the accelerator to get it back up to a run state. So to come up to the center of mass 14 TeV, yeah. Yep.
What's it doing now? What's it trying to accomplish since it's already discovered the Higgs?
Well, that's a question for Jeff Taylor rather than me, right? But okay, so you used an interesting word, the Higgs. So what's been found is a Higgs, potentially, right? Yeah. Firstly, there's uncertainty whether it is the Higgs, and then Jeff will argue if he walked into the room, right? Now, what size, what colour, how many, which one? Right. So having found the Higgs, or a Higgs, you really need to thoroughly understand it. Now, theorists, Andrew, you're an experimentalist or a theorist? Yeah. Yeah. So there are many, love that answer. So there are many theoretical predictions as to how the Higgs should behave, what should it be, its spin, its parity. In other words, what we found in the first run is the mass of the Higgs. Now we really need to study it, understand its spin, understand its parity, and also search for, could there be any more? So that's what may go on. Okay, so our work is in accelerator physics and detectors. So we actually don't analyze the actual collision data, but we do analyze data that comes from the accelerator and trying to understand how to actually collide the beams better, right? Or collide the beams full stop. So our work involves our particular group makes sensors that try to determine how stable the proton beams are, where that information is very important then to collide those beams. So if you think about it, the accelerator is 30 kilometres, 27 kilometres of ring. Protons will travel many, many thousands, hundreds of thousands times around. So it's a pretty long distance to go around. And you've got two beams, and then somewhere in space, 100 metres underground, you're going to try to collide those two beams. Yeah. Right? So you better know exactly where those beams are, how stable they are. So we work on technologies that actually do that, or we contribute to that.
Okay, so like from Australia, you're saying, okay, we've worked it out that if you build this or do this.
Yeah, well, from Australia, say 2 of our students have built a little gizmo that helps actually detect a proton beam. If you think, if you've got a proton coming through in a beam pipe, and you want to work out where it is, the last thing you want to do is destroy the proton in trying to find out where it is. So you have to come up with non-invasive ways of actually detecting where they may be. Yeah. So we build the sensors or the detectors to do that. Yeah.
Is that ongoing work, or is that just a? Okay.
Yeah, it's ongoing work. See, now the data takers will have the machine for the next 3 years. In the meantime, we'll have to try to plan what's the next technologies that we want to get into the tunnels, in 3 years' time down there.